it is Mr. Ranieri here, and we are going to learn about some different kinds of quadrilaterals. When I say quadrilateral, quad means four. So a quadrilateral is a four-sided shape, a four-sided polygon. So any four-sided polygon, if it has four straight lines, then it is a four-sided polygon, and it is a quadrilateral. We have shapes that are a special kind of quadrilateral. We have special kinds of quadrilateral. One of them looks like this. It is a quadrilateral with one pair of parallel opposite sides. Notice that this line here points in the same direction as this one here. They're parallel. What do you think this shape is called? It is called a trapezium. We also have a special kind of quadrilateral, which is where both pairs of adjacent sides are equal in length. That looks like this. When I say a pair of adjacent sides, I'll just change my color to something a bit different. There we go. So this side here and this side here, these two are adjacent. Adjacent means next to each other, and they're equal. And also the other pair, this one here, and this one here, these two sides are adjacent. So this is a pair of adjacent sides, and these are also equal to each other. Maybe not the same length as the first pair, but they're equal to each other. Do you want to have a guess what this shape is called? It is called a kite. We have a special kind of trapezium, which is a quadrilateral where opposite sides are parallel. In other words, both pairs of opposite sides are parallel, and it looks like this. Notice that it is more specific than a trapezium. It is a kind of trapezium, but it's more specific because both pairs have to be parallel. Do you want to guess what this shape's called? It is called a parallelogram. We also have a special kind of parallelogram, which is a quadrilateral, four-sided shape. The definition that it is a four-sided shape, a quadrilateral, where all four angles are 90 degrees, and it looks like this. What's this shape called? It is a rectangle. These descriptions in blue, by the way, are definitions. This is the definition, the meaning of a rectangle. If it matches the definition, then it is a rectangle. We also have another special kind of parallelogram, which is where all four sides are equal. The top, the bottom, the left, and the right, all four sides are the same length. Do you know what this one's called? It's called a rhombus. It's like a wonky square, although a square is a kind of rhombus. And finally, let's get to the last one. The last one here, a special kind of quadrilateral, is where all sides are equal and all angles are 90 degrees. It looks like this. Notice that the top side, left, bottom, and right, they are all the same length, they're the same size, and all four angles are 90 degrees. What's this shape called? It is called a square. Now, some people look at this diagram and say, okay, well, if I have a shape that looks like this, there we go, there's my dodgy diagram. I'll put these symbols to show that all four sides are the same length, and I'll even put the right angles to show that they're all right angles. And they've got a question like, is this a rectangle? Is the answer yes or no? Is this shape a rectangle? The answer is yes, because all four angles are 90 degrees. It matches the definition of a rectangle, so this shape here is a rectangle. And in fact, every square is a rectangle. So just because something fits a definition, like down here, a rhombus, every rhombus is also a parallelogram. But not every parallelogram is also a rhombus. To get into that, let's look a little bit more deep about the difference between the definition and these categories. The first one here is, are all squares rectangles? Is every single square a rectangle? Yes, because a square has all angles 90 degrees, a rectangle just has angles 90 degrees. All squares match this definition. Sure, it's a special kind of rectangle, but every one of these is a rectangle. Are all rectangles squares? Can you draw a rectangle that is not a square? No, not all rectangles are squares. Like this shape here. This shape is a rectangle, but it is not a square. You can see the sides are not the same. If it's a parallelogram, could it also be a square? A parallelogram has opposite sides parallel, and yeah, it could be a square. Like this shape, the way I've drawn it here. I'll draw that again. Notice that the top and the bottom clearly, very obviously, are the parallel. They're pointing in the same direction. And the left and right are parallel as well. So if it is a parallelogram, it can also be a square. A square is a special kind of parallelogram. If it's a parallelogram, does it have to be a square? Can you draw a parallelogram that is not a square? Well, if it's a parallelogram, it does not have to be a square. It could look like this. It might be a square if it's a parallelogram, but it doesn't have to be a square. If we know that opposite sides are parallel, does it have to be a rectangle? Oh, sorry, I missed that one. If we know that opposite sides are parallel, does it have to be a rectangle? Well, no, maybe it looks like this. Or maybe it looks like this. So if we know that opposite sides are parallel, then it's definitely a trapezium, maybe a parallelogram, but it doesn't have to be a rectangle. Could it be a rectangle if opposite sides are parallel? Yeah, if opposite sides are parallel, it might be a rectangle. Now, if this is all seeming a bit confusing, the difference between the categories, one thing that might help, a comparison, an analogy between rectangle and square is rectangle is like finger and square is like thumb. Oopsie. So you have 5 thumbs on your hand. Sorry. No, you don't. You have 5 fingers on your hand, right? Every thumb is a finger. A thumb is a finger, right? It's the big stumpy finger on the end. A thumb is a finger, but not every finger is a thumb. That's what I mean when I'm drawing these lines here. All right, so hopefully this has helped with the difference between 4-sided shapes, quadrilaterals, specific kinds of 4-sided shapes. Next, I'm going to go into the properties of a square, the properties of a parallelogram. All right, see you in the next video.